So here's the plan. I have this device, which is used to hold strips of surface-mounted tapes, like this right here, at a known location and position for building circuit boards using a pick-and-place machine. And what I want to do is create some injection molds for the different parts of this. In this video series, what I'm going to do is take you through the process that I followed for creating this set of parts as injection molds for milling the parts and then for injecting them. This is it modeled in SolidWorks, and the next thing I want to do is design an injection mold. The first part I want to injection mold is this one here. You can see it's a fairly simple part, and if you look at sideways you can see it has an angle on it. This is called draft angle. This draft angle is about 5 degrees. The purpose of this draft angle is to make it a lot easier to pull out of the mold, because the plastic shrinks as it cools by a little bit, and if all of the lines are perfectly straight, particularly lines like this one down here, it can shrink against the mold and be very hard to get out of the mold. So I have a draft angle pretty much everywhere except for this right here, which I want to be flat. I hope it's not going to cause a problem. We'll find out. The other place where I don't have a draft angle is right here. The reason for that is because I want it to actually stick to one side of the mold so that I can have some ejector pins that push against here and against here to push the part out of the mold. At least that's the theory. We'll find out how it works. For creating the injection mold, I decided to switch to Fusion 360. The main reason for that is because of the CAM operations. I'm still very new to Fusion 360, but it should be able to generate all of the machine operations for my CNC milling machine. I can show you what I have so far and then give you an idea of how I created it. This is a two-part mold. It's what's known as a straight pull mold. Let me turn off one side. You can see there's a cavity here. This is where half the part has been essentially subtracted from the aluminum part that I'm going to use for the mold. And then here we have what's called the sprue and runner in the gate system. The molten plastic comes through here. When you first inject the plastic, at least from my machine, there's a little bit of plastic at the end that's slightly solidified, so we want that to go here. That's called the slug. From there, we want it to travel out along these lines and into the mold itself. The rectangular part here is called the gate, and I don't have this exactly the way I want right now. I'm going to need to do some more adjusting on it, but it gives you an idea of where I'm going. A couple more features. Right here, this is an air vent. It's fairly shallow. If you look at the depth, you can see, actually it didn't do it, control. Okay, you can see it's only 0.02 of an inch deep. That's deep enough so that air can escape, but not deep enough so that plastic can get into there. As the plastic flows, it's going to flow toward the center and also flow toward the end, so we need to let the air out here. I may also have to add another vent up here and perhaps in some other places. It's easy to add additional air vents with them, manually with just a few light passes after I've made the mold and when I find out where it's difficult for the plastic to flow. When I first make this mold, I'm going to make it as a manual mold rather than an automatic mold. And the difference is with manual mold, there will be no ejector pins. And because there won't be any ejector pins, it means I'm going to have to pull the part out of the mold myself. With ejector pins, the machine can automatically push the part out of the mold. Because it's going to be a manual mold, I have these two slots here and here, into which I can fit a screwdriver blade. And then what I can do is twist both of the screwdriver blades and pop the two mold halves apart. The final feature of the mold is here and here. I have holes for alignment pins. Now, one of the things I realized is that the way I drew this, the hole goes all the way through. That's okay for now. When this is a production mold, I probably want to have them captured in there I'm also going to want to have it be a press fit on one side and a loose fit on the other side. So I'm going to mill these holes slightly underside size, and then I'll use a reamer to increase the size. I'll use an underside reamer on one side, which will be the fixed side, and then I'll use an oversized reamer on the other side, which will give me a loose fit, and that'll be the sliding side. Now let me show how I went about creating this mold. Alright, I'm back in Fusion 360 with an empty model. I want to give you an idea of the process that I went through to create the two halves of the mold. I'm probably not going to go through all the steps because it's a lot of steps. Before I started, you can see I have some models in here. I have the mold that I showed previously. I also have just the cavity. I originally started by creating the cavity in SOLIDWORKS because I'm familiar with SOLIDWORKS. But then I decided it would be probably easier to create the mold in Fusion 360 because then the cam will be tied to it, and it'll be easier to modify the mold and make changes and not have to go back and forth between SOLIDWORKS and Fusion 360. So the part itself, though, is in SOLIDWORKS, which is this part here. The way that I got that into SOLIDWORKS, and this is really cool, is just by clicking the upload button and then selecting a file, and you can import the SOLIDWORKS file directly. That's really cool. It means I don't have to export anything in SOLIDWORKS. The other thing that's cool is that if I make a change to the file in SOLIDWORKS, I can say import new version. And that means I can go back and forth, make changes to the model in SOLIDWORKS, and then come here. But by sticking in Fusion 360 for everything else, I have a single tool for all of the mold making part. If I were to start over, I think I'd do all of the modeling in Fusion 360. Once you have the part, then one of the things you can do is you can insert into current design. But you'll notice that I get a warning says, please save the file first. So the first thing I have to do is save this model. And I'm just going to call it demo mold because I'm not going to keep this. This is just for the blog, the video blog. Once I've saved that, I can now go back here and say insert into the current design. Here it is. It gives me a chance to move it. I'm actually happy with the location because it turns out that this face here is going to be right on one of the these planes. I'm not sure which one. But this is going to be right on the plane. And here, if we look at that, let's see, turn these on, you can see right there, it's right on the plane, which is perfect. It's going to make modeling a little bit easier. All right, let me turn that back off. All right, the first thing I want to do is I want to create mold half. And I'm using aluminum for this because it's cheap and light. What I want to do is create a rectangle. So I pressed R for rectangle, and I'm going to put it onto, I must have hidden one of those. Yes, I did. Okay, so I want to put it, oops, let's undo that. Not sure what happened. Turn that back on. Press rectangle, click on there. There, that's what I want. Now I'm going to create the rectangle, like so, and I want it to be 3 inches tall by 5 inches. I just started typing the number and then press tab. Oops, it's 6 inches. But the other thing you'll notice is that this is in millimeters. I'm working in inches because my injection molding machine supports molds that are 4 inches by 3 inches. I'm hoping that I can make it work with 6 inches by 3 inches. We'll find out. So I want to change this to inches. And I just did that by clicking over there, change active units, and now it's in inches. So I'll double click on this and change it to 6 inches. Perfect. It's not oriented the way I want, so I'm going to, I want the part to be centered inside, or another way to look at it is I want the mold centered on the part. So the way I do that, I'm sure there are other ways of doing that, is with construction lines. I'll put one on each side, and then I'm going to make the same length. So I select a line, pressed escape, click on this, and then press X, which is the same as this right there, and that turns it into construction line. Then I'll do the same thing on this side, and I'm zooming it in because it's easier to find the center point and just the right location when I'm zoomed in. Okay, now what I want to do is I want to make those two construction lines the same length. So I'll click on equal, and then I'll click on the first one, and then watch when I click on the second one, it moves so that it's positioned horizontally. And if I click here, you'll notice that I can move it up and down, but oops, I'm not sure what happened there. I can move it up and down, but I can't move it left and right. Okay, it seems to be jumping a little bit if I move too far away. Now I want to do the same thing for the vertical side. So I'll say line. I'm choosing the center point, but there's no reason I have to. And then I want to get the first point there. Because of draft angles, you have to zoom in to see exactly where things are. So a line here. Okay. Set that to construction. And then I'll go ahead and make those two equal. So equal, click there, click there. And what I just discovered is that this point here was not attached to that line there. So I'll go ahead and click on coincident, click on that point, and then I'll click there. And now you can see it's also centered vertically, and all of these lines are black. And they're all black because of a trick that I learned from John Saunders, which is to go in here somewhere, and I forget where, but basically to tell it to show the lines as blacks when they're, don't know where it is, basically to show the line blacks when everything is constrained. So that way I can tell this is fully constrained. All right, we're out of sketch mode. By the way, I'm using a space mouse to move things around because I find it a whole lot easier. I've been using a space mouse for several years, and it just feels natural to me. But that's why you're not seeing me move the mouse when I'm rotating things. Okay, so the next step is to extrude this. So I'll go ahead and say create extrude, and I want to select this, and then I want to extrude it this way, which is down. And it just happened to select 0.5 inches, which is exactly what I wanted. Oops, but I realized there's a problem here. This is actually not what I wanted to do, because I want this sketch not to be in here, but to be in a new component. So let me see. I haven't done this. I'm going to try creating a new component. I'm going to call this, this is going to be the core. And let me see if I can move this sketch into the core. Bingo. Perfect. Okay, because I want that sketch associated with that core. So now what I'm going to do is, because the core is activated, now I'm going to do create extrude, select this, move it down 0.5 inches. And that is in a separate component. So if I go back here to the whole assembly, you can see I have these two components. Now it's a little bit difficult to see what's what. So one thing I'm going to do is I'm going to change the color on my imported part by saying appearance, and then I'm going to go to green plastic, drop it on that part. Whoops, it's not what I wanted. Let's try this again. Appearance. Let me try seeing if I can just say, click on this. Now it looks like I have to drag it. So I'm going to drag it onto a part that I know is raised and make sure it's selected. You can see it's a different color. And now, there it is. That's the way I want it. Where we're at now is we have the mold half. And if we turn off the part, you can see that there's nothing there. What we need to do is we need to remove the part from this blank. And the way we do that is I'll activate the core, and then I'm going to say modify, combine. And the target body is the part where I want to remove material. So that's this one here. And then the tool body is the part itself that I want to make. So it's what will be created out of injection molded plastic. So I'll click on that, and you can see it's set to cut it, which is perfect. That's what I want. And it also is checked keep tools. I'm not sure why I can't check and uncheck it, but it doesn't matter because in any event, I want that. And the idea of the keep tools is if we go up here, you can see that my tool is still there. The tool is this piece here. And if I hide that now, you can see it's taken a cut out of the core, which is exactly what I want. The next thing I'm going to do is I'm going to create the cavity, and we're going to do the same operations on the cavity. So I'm going to try something. I'm not sure if this will work. I'm going to see if I can show this sketch, but hide the body, and then extrude that so I don't have to start over again. So I'm going to click on this. Oh, that's cool. Okay, so yes, I don't have to draw that again because I want them to be identical. But what I forgot to do is when I sketch this, let's try that again. I want it to be a new component because I want them to be completely separate. So I'll go ahead and say extrude and do the same thing, but this time before I complete it, I want to say new component. So that way it won't be part of the same component, it'll be a completely separate component, which is this one here. I'll go ahead and hide that sketch, and then if you look and show the body again, you can see we have two now. One is the core, which is the bottom one, and then we have the cavity, which is the top one. So I'll rename that. All right. The next thing we want to do is I'll go ahead and hide the core. We'll show our part, and we're going to want to do a cavity on this as well by doing a combine operation. So I'll make sure that this part is the active part, and then I'll modify, combine, click here, click there. Perfect. That's what I want. Okay, so let's take a look. And there's the cavity. So if we look at the whole thing, you can see we've got both of the parts, and if I change the opacity on this to like 50%, you can see an outline of the part itself. I have the part turned off. You can see that's where it is, but we have a cutout on both halves of the mold for that part. Now the next thing I'm going to work on is the runners, the sprue, the runners, and the gates. And the sprues, runners, and gates are what get the plastic into the mold. I'm going to start working on the sprue and the runners. One of the things that you may have noticed is that the runner I had was somewhat curved, and I want the end of the runner to be at a very specific distance. The other thing that's interesting about the runner, let me just open the other model, is that you want to keep the volume of the material basically about the same as it spreads out, so that you don't create any resistance. So let me hide one of these. And what I'm getting at here is, if you look here, the diameter of this is quite a bit less than this. And the idea here is that the total area of this sprue here is the same as the sum of this area and this area, so that you keep the pressure the same going down both routes. And then it becomes constricted here just before it goes into the mold. And what you see here, this is a little bit longer than it should be. What I did before, and what I'm going to show you, is I used some equations to do all of this. So I can actually change a single value, and the size of this will change, the size of these will change, the distance here, etc. All of this will change. So I'm going to show you how I set that up. Okay, I'm going to hide the top part. I think it's the top part. Let me check. No, this is the part I want to keep. And I'll set the opacity back to 100%. So the first thing I'm going to do is I'm going to draw the curve. What I'm going to do for that second part of the part that goes sideways and then curves is I'm going to use this function here, which is the sweep. So I'm going to create a profile, and the curve I'm about to sketch is the control curve for the sweep. So that's the curve that the profile will follow when it makes the cut. Okay, so I'll create a new component. Always create a new component. I was just watching a video about that. And I'll call this one runners. Then I'll add a new line on this plane here. And I'm going to want that line to, I'll just make it a straight line. It doesn't really matter where it is. And then at the end of the line, I'm going to want to add a curve. So I'll use the arc, tangent arc. And then I want the top part of the tangent, I want this distance here to be a certain amount. So I'm going to go and draw a straight line, but I'm going to make that a construction line. And it's not becoming vertical, but that's okay. I can make it vertical afterwards by doing horizontal vertical constraint. Whoops, I didn't touch it. All right, so I'll do this, touch that, and now it's vertical. And then I'll do construction on that as well. This will ensure that this is horizontal here and this is vertical here. Okay, the other thing I want to do is I want to make sure that this is in the center. So I'll draw another line starting in the center here, going up to there, and then I'll go to horizontal vertical constraints, and then make this a construction line. So now I know that this is exactly where I want it to be. The final thing I want to do is I want to make, I want to break this up into fourths. So the idea is that when the gate here will fill up the left side up to about the middle, and the same thing with the right. So dividing this into fourths will do that. And this is about 5 inches long. So I'll just make this distance here, dimension, to this distance here. I didn't get it correct. Let's try that again. So this distance, that's interesting. Let me try it one more time. Click on that line. And I'm not sure why it's doing that. Let me try a different approach. So I'll control click these two and then say dimension. Okay, that worked. So I want this to be 5 divided by 4, and it's easier to just do the calculations. The other thing I'm going to do is I'm going to stop the sketch, because I realized one of the things that I want to do is I want to go back and define, let's see, I have to find it, I forget where it is, change parameters. And I don't know if that has to be done before or after in the history, so I'm just going to go back and we're going to say change parameters. And I'm going to start by creating a new user parameter that defines the radius of the sprue. And initially I'll set that to 0.08 inches. I'm not sure what a good size is, so I can change that later. All right, so now we've got that. I'll go back to this equation, this curve, and now I can change some of these things to be based on that. So, for example, I want to set the dimension on this so that it's the sprue radius times 2, I think, and probably times 4. And then this is the important distance here. So what I'm going to have on the end of this runner is I'm going to have a curved cap right up here. And that curve will extend out to to the radius of the runner. And then I want the distance from there to be, I think, about 20 or 30 thousandths of an inch, for the length of the sprue. I have to go back and look at what I used in the past. It's been a couple of years since I created molds. But I'm going to go ahead and set that now. So I'll say that I want this to be equal to, I'll just do that so I don't have to type it, the sprue radius minus 0.03. Okay. It doesn't look like I got that right. Okay, I guess that is correct. All right. It still doesn't look correct because it says 50,000. The sprue radius I thought was more than that, so let's have a look. Change parameters. Okay. So that should be right. So let me do 0.1. Okay, so it does seem to be working out. If it's wrong, I'll come back and fix it later. And then the last thing I want to do is I want to mirror that. I can either mirror it now or I can mirror it later. I think I'll just hold off on mirroring it now. All right, so that gives me the basically the path for the plastic. So now what I'm going to do is go ahead and sketch the runner. The runner is going to go from here to a little past here. So I'll add another curve, arc, a 3-point arc, and I'm going to add it to this surface here. And then I'll just draw it, and I'll put everything where I want it to be later. Now the first thing I want to do is, I mentioned, okay, so I don't want these to be too close to vertical where they touch the top, because then that makes it harder to pull parts out of the mold. So I'm going to want to have this point be above the parting line so that this is not a full half circle. So I'll dimension that, and I'm going to set it to 0.01, I think, for this one. Okay, and then I want these to be coincident to that line there. Okay, like so. And then the other thing I want to do is I want these two to be coincident, but I don't think I can do that. I think I have to project it first. I'm going to try it anyway though. So you can see I can't select this, which means I have to click on that, and then I think if I do project, yep, it's picked that up now. And so now what I can do is I can add a vertical relationship between these two. So that this half circle here is centered on that line. Finally, I want to add a dimension to this, and this is going to be our sprue radius. And I'm just selecting values that I already typed so I don't have to type the full name. And there we have it. Okay, finally what I want to do is mirror this above. So I will select mirror from here, click on this, and then the mirror line is here. And if you look carefully, you can see that this is in fact not a full circle, and that's because of this separation right here. All right, and the sketch. And now what we're going to do is extrude that. And what I want to do is I want to extrude this so it's past this point here. So I'll say extrude, and then I'll say to object. So go right here. Oops, I forgot to select the profile. That would help. Okay, so now that's up to the object, and then I want to give it an offset. So the offset, I don't need a lot of offset because I'm going to put a cap on the end of it. So I'll give it an offset of about 50 thousandths. Now that went the wrong way, so I'll change the direction by making it negative, and there it is. Now it made my other sketch disappear, which I think was in the core. It was in the cavity. Oh no, it was in the runners. Okay, so I can show my sketches. And now there's something you'll notice here. It's hard to tell which sketch is. So it's a good idea to give these sketches names. So this sketch here is the runner curve. So I'll just call it runner curve. And then this one here is the sprue cross section. So I'll just call it sprue. And then that makes it a lot easier to figure out what's going on when it's time to go back and edit things. All right, the next thing I wanted to do that I mentioned is to put a cap on here. So I'll go ahead and I think I can just project this. Let's see, project, yep, onto this plane here. Did that do what I want? Yes, I think so. No, it didn't. Okay, so I'll try project again. There we go. Oops. Okay. And I want both. I just need one of those. So I have that line there now. And then I need to close it so that I can rotate this around. So I'll add a line here. Okay, stop sketch. And if I've done that correctly, now I can go in here and say revolve. Select this profile. Okay, that's not doing what I expected. So let's see if we can figure out what's going on. Let's hide the body here. All right, so it's pretty clear that I ended up projecting a lot more than I expected to. So I'll go ahead and I'll just delete this sketch and turn this sketch off. And then I'll go back and try doing the projection again. So I'll say I want to project here, and this is what I want to project, and then I can draw a line across. And that should do it. Okay, then I'll go and rotate, revolve. Select that, select the axis, and I want it to be joined instead of cut. Okay, so if we turn our cavity back on, so the core, you can see that this is exactly what we want. And if I turn the runner curve back on, you can see that this does in fact project. It may not be enough. Actually, I just realized it isn't enough, but we'll fix that later. Now the last thing I want to do again is to rename this sketch. Double click on it, and this is the sprue end cap. Now I want to draw the cross section that I'm going to sweep along here. To do that, I need a plane. And so one easy way to add the plane is with midplane. And so I can use this face, and now I have the exact midplane that I need. And then I could sketch on there. So again, I want to use the arc like I did before. And I'll use the 3-point arc again on here. And then I'll just draw it and then put it into place after I've drawn it, because I find that works pretty well. And one of the reasons I did that is because I'm going to want to use a projection of this. So I'll say project, click on this, and now I'm going to want to have a vertical horizontal relation between those two, like so. So now if we look at this, you can see that they are the way I want them to be. The other thing is, you can see that's moving around quite a bit. That's okay. I'll just constrain these. Pull this down a little bit. Okay, this is I'm going to undo in a couple steps. Okay, So what I'm going to do is I'm going to go here and do a coincident constraint and try this, and this, and then this, and this. So now they're where I want them to be. Then I'm going to add that distant constraint that I mentioned before, dimension. And again, I'll make this about 10 thousandths above. And then I'll set the radius on this. Now, this is using, needs to use a square root of 2. And I don't know how to do that, so I calculated it. So we want to divide by 1.414, I believe it is. And this will make it so that the area of this almost circle is half the area of this one here, so that when it extends out the two directions, it'll be the same volume of plastic moving at the same rate. And then I want to mirror this. And the mirror line is here. Okay, we can stop sketch, and if we take a look, that is what we want it to be. So let's go ahead and sweep that. So the profile is right here. We have to click on both the top and the bottom, and then the path is here. We don't want it to be cut, we want to join to what we have already, because we're going to do a cut later on between the top and the bottom. And there you have that part. Then we need to put a cap on here, just like we put a cap on there. Again, what I'm going to do is I need to keep remembering to rename things. So this one was the, let me just turn that on to make sure. Yep, this is the runner cross section. Okay. Going here, this will be the runner end cap. So let's click on this, do projection. Okay, and then I want to click on here. Why can't I click on there? Let's try this. Not sure what this does. Okay, so I'm going to cancel and I'm going to try that again. First thing I'm going to do is going to hide the cavity, so I'm not looking at as many things. I'm also going to hide this other sketch that we don't need. So we have this new sketch here that we're working on, and so I'm going to click on this again and say project, and now it's working. Not sure why it didn't work before. Then add the line across, and now we can revolve, or yes, revolve. Okay, so that's the profile, axis, and then join. Okay, so we'll turn our cavity core back on, and you can see it's left a small gap, which is, let me make this a little easier to see. You can see it's left a small gap there, which is exactly what we want. We want a small gap between that and the part, and that's where the gate will go. So the next thing I'm going to do is I'm going to draw the gate. And I'll go back to the runner and activate that again. And then I'm going to add a new rectangle to right here. And the rectangle I'm going to want to be centered on this here, but I also want to, to get it down as close as I can. So I'm going to make these collinear. And then how do you center it? Well, the way that I've found to center it is I'll just move this off to the side so it does what I want it to do. And then I'm going to add a construction line that goes from this center point here to this center point there. Then I can make this vertical and construction line, and now my rectangle is centered. So the next thing I want to do is dimension it. I'm going to make it Yeah, that looks about right. 60 thousandths, 70 thousandths. I'll start a little smaller. I can always go back and remill it and make it larger. And then I want this to extend out past this a little bit, because I'm going to be adding some draft to this gate. And so this will make sense in a little bit. And it doesn't matter how far I put it out, just so it's far enough. Okay, so I'll rotate so you can see how that's sitting. Okay, looks good. I'll extrude that. Okay, and I'm going to want to go this way. I'm going to be doing a join again. And I want it to go down, I think, about 40 thousandths. I'm going to rotate. We can even go down about 50 thousandths. Yeah, that looks good. I didn't want this to come too far back. Then I'm going to set the taper angle. So let me give it an angle of 10%. Now that's going the wrong direction, because the top of the mold is here, and this is going to end up being an undercut. So we need to make it minus 10 degrees. And now it's going to make it easier to pull this away from the mold. Okay, so that's extending it apart, but that's okay, because what we're going to end up doing is subtracting this from this part here. The last thing I want to do is I want to mirror all of these features over to the other side. So I remember that I created a sketch plane. Here's the plane, so I'm going to show that plane. And now what I'm going to do is say mirror. And what I want to mirror are, okay, I'm not sure why I can't select them there. Pattern features, that looks good. So let me try down here. So we want to mirror the, no, not the cap. We want to mirror the sweep, the end cap, and the runner. And then the mirror plane is here, and that did it. Cool. So now we have the whole thing. I'll hide this plane again. One of the other things you can do, by the way, is, I've been trying to name things here. Because I'm talking and doing this at the same time, I forget quite often to rename them. But naming them makes it a lot easier later on when you're editing. So I'll double click on this. Whoops, that was not what I expected. Slow double click. Okay, and this is the, oops. Which one is this? That's the gate. Okay. And then this one here is the, okay, I didn't select that right. Let's see if I can rename it this way. I haven't quite gotten the correct combination of keys. All right, this is the runner end cap. Now, in addition to naming these, you can also name these operations down in the history. So, for example, I have this, actually some of these are named, but this one here is not. So it just says extrude, and it's extruding the sketch that I've renamed. Oh, okay, that's what's going on. But you can also rename the features. So instead of extrude 1, I can rename that to be sprue. And now if we hover over this, you can see that it says sprue, and it's runners. Likewise here, I could rename all of these, and I often do, because then when it's going back through the history, it's a lot easier to figure out what's going on. But I won't do that right now. So the next thing we're going to do is go back here and activate this so we can see the two together. Everything looks fine here. So now we're going to activate the core, and I'm going to do another combine operation to remove the runner here. And actually, let me see if I can edit this feature to include it. And no, I can't, because this happened before I added the runners. So I'll just add a new feature. I'll go ahead and say modify, combine, target body, tool body, cut, and Now this is enabled, but we do want to keep the tool. I think I did that correctly. Yes, I did. And you can see if we go back up here and hide the runner, that we now have exactly what we need. And then we would do the same thing for the cavity. And that pretty much gives us the mold, except for adding the alignment pins and also adding things such as the slots for the screws, etc. Those are fairly straightforward, so I'm not going to go through those. I just wanted to give you an idea of what's involved in building a mold in Fusion 360, which is really nice because you're doing in-place modeling with different components. So it's really easy to do all of these things. The next video, I'm not sure how long it's going to be, but in that one I'm going to start doing the cam, creating the tool paths for milling one half of the mold, and then we'll take it to the milling machine and make some parts.